All right, so lesson 4.2, negative exponents. Make sure you have that written down, okay? Anybody still need this? Are we good to go? Okay. So first thing I'm going to do is I'm going to just talk to you about how powers work a little bit. I didn't get a chance to do this yesterday, so I'm going to do it today, okay? So 2 to the 6th power, I have the value as 64 up there. But what does that look like? Like, what does 2 to the 6th power actually look like, Dylan? Yep. Okay. All right, that makes sense. And then 2 to the 5th power looks like what? 2 and then 5 times, right? Okay, and then this one would look like this. And this one would look like this. And this one look like this. And this one look like this. Now watch. Some people say, why is anything to the 0th power always 1? It, well, 2 times 0 is what? Okay, now listen, I'm going to explain to you why it works. Okay, now watch. What happens from here to here? What happens from 2 to the 6th to 2 to the 5th? What happens? It goes down, it goes half. Because what's happening? I'm dividing by 2, and when I divide by 2, I get rid of a 2, right? So I got rid of a 2 here, and then I got rid of another 2, and I got rid of another 2, I got rid of another 2, and I got rid of another 2, all by dividing, right? Because I had to divide this by 2, I divided by 64 by 2 to get 32, divided by 2, divided by 2, divided by 2, divided by 2, and when I take 4 divided by 2, I get, and when I take 2 divided by 2, I get, that's why anything to the 0th power is always 1. Make sure you write that in your notebook. You're going to want to know that. Anything to the 0th power is always 1. No matter what base it is. It could be 8 to the 0th power, it's going to be 1. 10 to the 0th power is going to be 1. So many people say, well, if it's something to the 0th power, the answer is 0. Not true. And the reason is because obviously we talked about it. You keep dividing by 2, divide by 2, divide by 2, divide by 2, divide by 2. And when I divide by 2 here, 2 divided by 2 is 1. Okay? Does that make sense to you? I keep getting, and it works for any base. It works for any base. It could be 6 to the 2nd power, 6 to the 1st power, 6 to the 0th power. Any base, no matter what it is, you're always going to have 1 to the 0th power. Now today, this is what we're going to be talking about. Right here. We've talked about exponents to the positive exponents. Today we're going to talk about negative exponents. When you have negative exponents, your answer is always going to be very small. Now listen, we talked about remember how you're dividing by 2 every time? What if I divide by 2 again? What's 1 divided by 2? 1.5, or what does that look like in a fraction? 1/2. Okay. What if I divide by 2 again? Okay, so 2 to the negative 3rd power should be. Okay, now watch. Do you see the pattern? Anytime that I keep having a smaller negative, what keeps happening to this number? It keeps getting smaller. Yeah, you're thinking too hard. Don't think too hard. So listen, anytime that I have a negative exponent, my number is going to be extremely small. Now look, what is my number probably going to be? No, not necessarily. What kind of number is this? A fraction. Anytime I have a negative exponent, my number is going to be a fraction. Write that down. Anytime I have a negative exponent, give me 1 second here, my number will be a fraction. First, Evan, you had a question. No. No. Yeah, I know. Some people think, well, if I have a negative exponent, pretty soon my number is going to be negative. Not true at all. It just means it's a super small number. Yeah. Yep. No. The only reason why it's a half here is because of that base. I'll show you another example. Okay? Okay, well, then we're going to keep working with 5s. I'll do 3s. Okay? I'll do 3s. You don't even have to write this chart. What's that? Well, I'm just showing you because I think 2s are easy to understand. Okay, can I show you 3s? I can do 6s, but 3s we can do easily in our head together. Okay? Alright, so let's try 3s. So let's do, I'm going to start easy. 3 to the second, 3 to the first, 3 to the 0, 3 to the negative first, 3 to the negative second. So 3 to the second power would be 9. Okay, 3 to the first power should be 3. 3 to the 0th power should be, woohoo! Okay, now look at here. What keeps happening? I keep dividing by what? Okay, so what's 1 divided by 3? Okay, 33.3 repeating, right? But what does that look like in a fraction? 1/3. Yeah, 1/3. Okay, and then it'd be, no, if I divide this by 3 again, it's going to be 9. And if I divide by 3 again, it's going to be, okay. Okay. Okay, so you're starting to make some guesses. I like this because my other class did do this. Okay, so what do you see that's happening? Okay, so Brian, tell me what you see that's happening. Okay, okay, so you're seeing 1/3 times 1/3. Okay, what do you think? Anybody else? Maddie? Okay, so what were you going to say? Yep, you're right, but I'm going to have Carver try to explain it. What do you... Okay, if you just put a 1 over on top. You guys are so good. Yeah, you guys are right. Okay, now listen. I'm going to go to another slide, and this is what you need to start writing down, okay? So, here's what's going to happen, and you are all right. Anytime you have a negative exponent, first thing that's going to go over the top is what? A 1. You guys told me that already. Then what's going to happen is you're going to take that number, or that base, the big number, and the little number is the exponent, and you're going to put it underneath. And then sometimes you can evaluate it, and we'll go back. I'll show you that in a second. Hold on. Yep. No, it's always going to be a 1. And then somebody in the other class asked me, do you ever reduce? No, you can't reduce because it's always going to be 1 over something. Okay? So here's an example right here. Let's say I have 5 to the negative 4th power. Well, we could make our chart, but we don't need to. It's going to be too long for one. Who wants to do that? And I'm going to put a 1 over the top, and guess what I'm going to put underneath? The base and the exponent. Sometimes you can solve it, and we'll come back to that. Okay? Sometimes you do. And I'll show you when you're supposed to do that and when you're supposed to stop. Okay? Enter. Oh, sure. If it's like this, then your negative just comes underneath. Okay? So, and I'll show you an example of that too. Okay? So, let's do a few together. So, I want you to write this down because in your book it has certain directions. And this direction is really important to know what to do for your problem. So, write an expression using a positive exponent. That's what's going to be in your directions, and I want to make sure you know how to do that. Write an expression using a positive exponent. And you're going to do exactly what you just told me. You told me, first of all, you're going to make this into a what? A fraction by putting a what over the top? A 1. Okay? And then, when I do that, I lose that negative sign. I lose this. It goes away. And the rest of this just comes down, negative 3 to the 2nd power. I just wrote this using a positive exponent because what's positive now? That 2. Mix, all right, yes. Right, and then sometimes, you guys, when it says using a positive exponent, I can stop here. I don't have to go any farther. If it says evaluate, that's when you say, oh, okay, now it's neg 1 and 27. If it says evaluate, then you take it this far. If it just says write as a positive exponent, this is all the farther you need to go. Oh, my bad. You guys are all looking at me funny. Sorry. So this, when it says evaluate, that's what you're going to do. If it just says write as a positive exponent, That's what you're going to do. Brian. No, negative 3 times negative 3, positive 9. Okay? Okay, so if I say to you right here, 6 and negative to the negative 4th, write this in a positive exponent, what are you going to do? You don't solve it. You go 1 over 6 to the 4th power, and you stop. That's it. Unless it says to evaluate, and I will point out in your to evaluate. Okay? Yep. Because as soon as right, that negative basically comes and turns into that one. That negative tells you it's going to be a fraction. It's going to be a super. Okay? Is everybody catching what I'm throwing? Okay. So, now let's go backwards. Let's not even worry about this one yet, and let's not worry about this one. Let's talk about this one. In your notebook, write this. Write these fractions with a negative exponent. Okay? Write these fractions using a negative exponent. Now we're just going to go backwards. You don't have to write this right now. I want you to write this. Then we're not going to worry about 1/8 and 1/9 yet. Yeah, some of you are already thinking, oh, okay, I think I know how to do this. Okay, so if I look at this one, 1 and 7 to the second, 1 over 7 to the second power, I want to write this backwards in a negative exponent now. Dylan, what am I going to do? That's my answer. That's it. That's easy. Yeah. These two are a little different. Yes. You want to do that one? Okay, so hold on. Should we go with this one first? Yeah. Okay, so Hunter, what do you think you're going to do with this one? I can't use 1. Okay, so first of all, I can't have 9 to the negative first power, or 9 to the first power, because can I break 9 down farther? Is there something times something that gives me 9? Okay, so what gives me 9? 3 and 3. And 3, so that'd be 3 to the second power, right? Okay, so really, this is considered the same thing, right? Okay, now change that into a negative exponent. Good job. So make sure you're getting some of these examples in your notebook. You're going to want some of these. Hold on, yep, hold on. Let's let some people write some examples in their notebook. Okay. All right, so let's talk about this one. And if I were you, it's really easy to do arrows. Okay, so what do you know, Dylan? Okay, except for... So you're thinking the other way around. So really, this looks like this, right? 2 to the 4th power, right? 8 is 2 to the 4th power. And then it would be 2 to the negative 4th. 4 to the second power would be 16. Is it third? Who's telling me 4th? Oh my gosh. You guys. Maybe it's just me. I'm going crazy. Probably. There we go. Okay, so is everybody kind of catching it? I'm going to do another one with you. Okay, let's do another one. What if I do... I'll just pull it down here. What if I do this? You can do it to yourself. Yeah, sure. Some of you will be able to do immensely. Larissa, what do you think? Okay, so it's going to look like this. But if I want to use it with a negative exponent, then what am I going to do? Yes. Good job. Let's do this one. Let's do this one. Let's do... I'll show you about your homework in a second. I'll show you about your homework in a little bit. Let's just keep practicing. What if I have this? Okay, now here's the thing. I could do 10 to the second, right? But if I break this down, I would have 2's and 5's. What they want you to do is they want you to have a number that's consistently multiplying by itself, so like 10's. So this would be like 10 to the second power. See if I would like do my factor tree, I'd have 2's and 5's in my factor tree. Be like 20 to the no 20 times. That's way high. 5 to the well, here, let's see. So it'd be like 2 and 50 and 5 and 10 and 2 and 5. Do you see how I have a whole bunch of different things here? I could do 2's and 5's, but what they want is they want just a number that multiply itself to get that. So like 10's would be fine. Okay? So then it would be 1 over 10 to the second, and then be 10 to the negative second power. And actually, what does this look like in a decimal then? 100th? Looks like that. In a decimal. So really, you can change anything that has 10's, you can change easily to decimals. Okay, so how are we doing so far? Okay. Alright, so here's, yep, you're starting to get it. It just takes a while. Here's another thing. Now look at it, says evaluate. So what we're going to do first is we're going to create it into a positive exponent, and then we're going to evaluate. So we're going to take a step further. So what does n mean? N is 2. So I'm going to rewrite it. 2 to the negative 4. Sorry, it's not a very good 4. Okay. And then it looks like this. So I'm just going to do it in steps. And then it looks like this, because I'm going to evaluate. Remember, it says evaluate, so I have to take it another step further. 2 times 2 is 4. 4 times 2 is 8, so it would be 1/16. Some of it. I'll show you. I'll show you what you have to do on your homework. Not everything says evaluate. Not everything. Not everything says evaluate. What if, I'm going to throw a wrench into you guys, okay? What if I have this? 3n to the negative second power. Whoa, 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 whoa. Okay, Maddie, go for it. So I got to figure out this. So it's going to be like this. I'm going to substitute. Okay, then what am I going to do? Right? Which would be 1/4. Yep. Okay. Do you want me to do that one again? Do you want me to do something like that again? No. No, that's what I talked about at the beginning. Remember I said if you have an exponent, it's always with that first one. Okay? So I'll do that one again. I'll go slower this time. Okay, so first thing I'm going to do is I'm going to rewrite it. Okay? And then I'm going to only work with this because that's what we've been talking about. So I know it looks like this, right? And then it looks like 1/4 if it says evaluate. Now I still have to multiply by that 3. So it becomes 3/4. Have to do what? Yes. Mm-hmm. Yep. Do you want to do another one like that? Okay. Let's do, n still is going to equal 2. So let's do 4n to the negative third. 4n to the negative third. So rewrite first. Please rewrite it first. Oh, this is the easy one. Yeah, I did too. It's pretty easy to do mentally, but still write it out because sometimes you need to do that. So then this looks like this. 1/2 to the third. So it'll be 4/1 times 1/8. 4/8, it would be 1/2. Should be your answer. What? Did I just stump the stumper? Oh! um, Carver, can I ask what you got wrong so I can think about what you did? Did you make this 6 2 times 2 2 times 3? Did you do that 6? Did you have 4/1 times 1/6? Okay. All right, let's practice again because you're going to have to do this again. Let's go back to what we first knew. Let's just write these in positive exponent form. You do not need to evaluate. Just write in positive exponent form. That's all I'm asking. Yeah, you should be able to easily do this. Yeah, all of them. Write all, and don't worry about the decimal part. I'm not going to worry about that. Okay? Write all of them in positive exponent form. Yes, that's fine. I'll come back to that one. Just pretend it's a number. Pretend that P is a number. Pretend. All right, ready? What is this in positive exponent form? Somebody I haven't heard from yet today. Larissa? Yes, very good. Nice job. What about this one? Right? 1/3. Or you could put it 1/3 to the first power. Either one's fine. What about this one? Carver? Okay, but it could be like this. 1/P to the 4th. Okay. If it's a variable, just keep it as a variable. If they don't tell you what it is, that's all right. Does anybody have questions for me? What if, let's do one more. Write this in negative exponent form. It's a Q. Write this in negative exponent form. So you're just going backwards here. Going backwards. What do you think? Anybody? What do you think, Evan? Q, -6. Nice job. We didn't do this one. Oh, try this one. Write this in negative exponent form. There's two answers to this. There's two answers to this one. Yep. Yep, two answers. Rain, what do you think one answer is? Okay, that's one answer. There's another answer to this. 3 to the 4. 3 to the -4th. Just double it. That's only one that, yeah, that's. Let's get your homework out, or let's open your book, because I want to talk to you about this a little bit.